from looking at it from a distance. But measuring the heat pumping out of this lava lake will give us a better idea of the true scale of the heat loss on Io. A small moon like Io changed our view of the workings of the solar system. It's out for an explanation. See, Io is far too small a world to have retained any internal heat, to have the same heat source that powers the Earth's volcanoes. So something else must be driving that powerful volcanism on Io. New images sent back from recent space probes confirm that Io is a surprising and bizarre world. Being so far from the sun, Io's surface is mostly very cold. It's covered in frozen sulfur, which gives it its yellow colour. Yet Io is pockmarked by cauldrons of molten lava. Before Voyager arrived at Jupiter, 3 scientists made a prediction, and it was one of those predictions that, when you see it, is almost obvious. It was using physics that had been known for hundreds of years, but nobody had thought of it. They predicted that Io should have an intense internal heat source because of its unique position in the solar system, very close to a giant planet and surrounded by other large moons. Io sits about the same distance from Jupiter as our own moon does from Earth. But don't forget that orbiting outside Io are its sister moons, Europa and Ganymede. Io is under the influence not just of the massive gravitational pull of Jupiter, but also the additional pull of its neighbouring moons. It's this gravitational tug-of-war that conspires to breathe life into Io. Now, Io has a very interesting relationship with Europa and Ganymede, because for every 4 orbits that Io makes around their planet, Europa goes around almost exactly twice, and Ganymede goes around just once. Periodically, they line up together, bang, 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 and Io gets a powerful gravitational kick on a very regular basis. And that has the effect of moving Io out of a nice circular orbit into an elliptical or an eccentric orbit. Io comes close to Jupiter and then far away from Jupiter and then close to Jupiter again. And because Jupiter's gravity is so big, that has the effect of stretching and squashing Io. Now imagine it was a squash ball. If you stretch and squash and stretch and squash, and it gets hot by friction, and the same thing happens to this moon. The power of the gravitational interaction between Jupiter and Io is extraordinary. It contorts the shape of this tiny moon, moving rock as if it were nothing more than water. Now this crater is about, 30 metres from the base that you can see down there up to the edge of the rim. Now Io, when it orbits around Jupiter, every 1.8 days flexes by something like 100 metres. That's 3 times the height of that crater. Remember, Io's surface is pretty much like this, solid rock. So imagine how much energy that takes. And all that energy comes from Jupiter's gravitational field, and that is the energy that powers the volcanoes.
This is the Turtle, built in 1776. One man inside pedaled propellers that moved the craft back and forth and up and down. The plan, during America's War of Independence, was to come up underneath HMS Eagle, a British warship, carrying a bomb, drill a screw into its hull, and leave the bomb hanging by a rope. But it didn't work. The hull was too tough. The drill wouldn't go in, and the man in the Turtle, now running out of air, had to pedal away. Finding enough power to stay underwater long enough had always been the Navy's problem.
-29 if you can make it front. Don't get too close to it. Brilliant! That was, look at that. I think that it just reached.
Of one of the most alien worlds we know. But it's an alien world on our planet. The Atlantis is the launch vessel for Alvin, one of the world's most rugged submarines. Built like a spacecraft, it's designed to explore the deepest depths of the ocean. And I'm lucky enough to have hitched a ride down to the sea floor, 2 kilometers beneath the surface. The parallels to spaceflight are obvious. As the tiny capsule descends, we're leaving the familiar world of the surface of our Alvin is one of only a handful of submarines that can withstand the colossal pressure of the deep ocean. At the Earth's surface, we're used to one atmosphere of pressure. As we descend, the pressure increases by another atmosphere every 10 meters, and it soon adds up.
You're gonna have to repeat that, or you would be.
So we're just approaching a kilometre deep. The pressure outside there is now, what, 100 atmospheres? That's higher than the atmospheric pressure on the surface of Venus. Without knowing, if you were asked the question, could life exist down here? 100 atmospheres, cold, dark, no sign of sunlight at all, it's pitch black there. You would say no. Well, I would say no.
But the depths of the ocean are not lifeless. Illuminated by Alvin's lights, we find oases of life in the deserts of the ocean floor.
My depth is 2013-2013, EV neutral trim.
So we've landed after about an hour of descent. We've just stopped in the most incredible place. Look at those. We've landed on top of the tube worms. Amazing things.
This It's built around a hydrothermal vent, a volcanic opening in the Earth's crust that pumps out clouds of sulfurous chemicals and water heated to nearly 300 Celsius. And somehow, life has found a way to thrive in these most extreme conditions.
It's a place where you, at first sight, would not expect a great many life forms to survive and flourish.
For us, that doesn't mean that nothing lives here. In fact, it's teeming with life.
But look at these fish just everywhere in the cave water, and they're adapted to live in these conditions. In fact, if you look at them closely, they're quite pink, and that's thought to be because they've got lots of hemoglobin, because there's not as much oxygen down here, and so they need to have an efficient way of moving oxygen around their bodies.
Is high enough to set off my alarm. Down here, far from the light of the sun, are organisms whose energy source comes from the air around them. They use the hydrogen sulfide gas bubbling up through these springs. The same gas that could be fatally poisonous to me is their source of life.
Well, these things are what I came deep underground to see. These are snotites, and you can see why they're called that. They're really one of the most alien life forms that I can conceive of on the Earth, because they metabolize hydrogen sulfide. So they metabolize this faintly acidic and nasty gas that I'm just breathing in now. You can almost feel it on your tongue, actually, the acidity of it. They metabolize it, they react it with oxygen, and they produce sulfuric acid. So their breathing process, if you like, their version of what I do, I breathe in oxygen, react that with sugars and produce, breathe out CO2 and get energy. These guys breathe in hydrogen sulfide and oxygen and produce sulfuric acid. In fact, I can test it here with this. Yeah, you see, look at that. well, what looks like water, that secretion dripping off the snotites, has actually got a pH of, well, it's now about between 0.5 and 0. I mean, that's strong acid. That's as strong as battery acid. It's actually highly concentrated sulfuric acid. So what a strange organism.
From the sun, the solar system becomes a very different place. The planets, like Saturn, are made of gas, not rock. There's plenty of water out here, but it's frozen solid. The planets are surrounded by networks of moons, worlds of the outer solar system. And in those frozen wastes, we have found one world that's of particular interest. It's one of Jupiter's moons. Jupiter has a vast network of moons. The 4 largest have been known since they were discovered by Galileo in 1610. And they are a varied bunch. Closest to the planet is the tortured moon Io. It's torn apart by volcanoes that carpet its surface with bright yellow sulfur. In total contrast to the heat of Io comes its neighbour, the ice moon, Europa. It's about the same size as our moon, and it's the smoothest body in the solar system. Its surface is made of an unbroken shell of ice, though it's etched with a network of mysterious red markings. It exists at a chilly -160 Celsius. It seems an incredibly unlikely home for life.
To see surface features, and those features tell you a lot about what's going on deep beneath the ice.
Close up, we can see deep cracks that crisscross the surface of Europa. At higher magnification, we see areas where the ice has been broken into icebergs and jumbled up before refreezing. We see the same formations in sea ice on Earth, where the movements of the ocean have caused the ice to bend and crack. It suggests something similar may be happening on Europa. But it's the way the cracks are broken and fractured that provides the compelling evidence that there is liquid water on Europa.
You see, as Europa orbits around Jupiter, Jupiter's intense gravity stretches and squashes the moon, and that stresses the ice and causes it to fracture and crack. But the position of those cracks is not quite where you'd expect it to be. And the explanation for that is that the icy surface of Europa has shifted, it's moved relative to the rocky core. And the only way that could happen is if there's a layer or an ocean of liquid water surrounding the rocky core that allows the outer ice surface to slip around.
Measurements of Europa's magnetic field have confirmed that its icy shell is sitting on top of a salty ocean that may be a staggering 100 kilometers deep. That would mean that there is more than twice as much life-giving liquid water on this tiny moon than there is on planet Earth. But it's not just the discovery of the hidden ocean that makes us believe that Europa may be the most likely home to alien life. And that's why I've come to this spectacular ice cave in the Vatnajökull Glacier.
Place. I mean, it's absolutely magnificent. Visually, the quality of the ice, it's just completely transparent and clear. You can see straight through it.
The cave tunnels into the heart of the glacier, where the ice has been frozen for 1,000 years. It's what astrobiologists find in this ice that makes us think that Europa could be teeming with life. NASA scientist Richard Hoover has spent his career looking for life in unlikely places.
Well, that went very well. Okay.
So will any organisms that you find in that ice be living in a sense that I wouldn't understand it? Like they're actually alive now and metabolizing?
For a long time, it was thought that ice microorganisms were present only in a state of what is called deep anabiosis, suspended animation. It's now becoming quite clear that that isn't necessarily the case for all the microorganisms. There may be others that are actually actively living in the ice.
That's quite incredible. So in this glacier, the whole place, this whole cave, may be populated by 1,000 millionths of a meter.
Yeah. We have bacteria. Yes.
So these are organisms that have been trapped in that glacier for
yes.
thousands
Look
of
at
years.
this. It's beautiful. You're seeing life in ice.
So it's amazing.
We now know that some microorganisms are capable of actually causing the ice to melt because they generate essentially antifreeze proteins. They change the temperature at which ice goes from a solid state to a liquid state. And they could have been forming little tiny pockets, maybe only a few microns in diameter. But if he can make a 2 or 3 micron diameter ball of liquid water, and he has the ability to move, then that bacterium is now not in a glacier, but he's in an ocean.
Implications of these discoveries, the fact that you've got living bacteria inside ice on Earth, what are the implications for Europa?
You can clearly have bacteria like this in the frozen ice near the surface crust. And the thing that is most exciting to me is that surface crust of Europa has a wide variety of colors that are highly suggestive of microbial life. And so there is a very, very strong possibility that the ice of Europa may contain viable, living microorganisms.
It's a controversial idea, but it is a dizzying thought that the mysterious red stains on the surface of Europa could be the visible signs of alien life. The discovery of the huge ocean of liquid water under the surface of this tiny moon, combined with the potential for life in ice and the intriguing red markings that crisscross its surface, have made Europa the most fascinating and important alien world we know.